Hello everybody. This is Mr. Harrison doing a lesson for my advanced math students. Today we're going to be doing the second half of lesson 63B, sketching sinusoids. We're going to skip 63A for now, factoring of trigonometric functions till we have more time face to face. Sketching sinusoids is really not very difficult at all. Guys have had a lot of experience with finding the equation of a given sinusoid. We're going to do this in almost the exact same order as what we do in finding the equation of a sinusoid. Just this time you're going to be drawing it yourself. I'm on pages 317 and 318 of your book if you want to follow along. The two problems that are written up here, the two equations are the examples in the book. I'm going to say sketch this equation. Y equals -10 plus 2 sine 3 quantity x minus 45. Here, this first thing you want to do with this is draw yourself just like a number line. And the fact that this right here says that you're doing a sine wave, so draw yourself a sine wave. Now you notice I did not start it here at this where the x and y axis cross. Namely because this really isn't, like this point right here is not point 0, 0. I'm not showing it as that. This is just a way to show how tall your graph is. So first thing, just draw your sine wave and put this gradation over here off to the left along the y-axis. All right. Now we're going to take this in the same order as we did when we tried to find the equation of a sinusoid. We always would look at the picture and we'd figure out the center line first. Well, right here, this tells me my center line is -10. So right here, left-hand side, this is my center line. Right there, I'm going to put that -10. This right here shows that I've got a positive sine wave, which I have drawn, and I've drawn just one. And it says I have an amplitude of 2, meaning this sine wave is too high and going 2 up and 2 down, 2 up, 2 down. So if I'm here at -10 and I go up 2, I'm here at -8. If I'm at -10, oh, I did that wrong. No, I didn't. That's correct. If I go down 2, I'm going to be at -12. All right. Starting at -10, going up 2 to -8, down to -12. We have just taken care of half of our equation. There's the -10, my center line, the amplitude of 2, and it's a positive sine wave, which I have drawn right there. As we always do in class, here is my frequency, the period. We're going to save that 3 for last, just like we always do. This x minus 45 is called my phase angle or my phase shift. That tells me that my sinusoid started at positive 45 degrees. Not negative 45 degrees, but positive 45 degrees. It's always opposite that. Had this been positive 45, x plus 45, we would be starting at negative 45. So right here, that's 45 degrees right there. This 3, the frequency, tells you that you get 3 sine waves in 360 degrees. And if you look in the book, they draw 3 sine waves, 3 complete cycles. You do not have to do that. What if that had been a 30? Would you want to draw 30 complete cycles? Of course not. So we just draw 1. But what does this tell us? I just mentioned it. I said that tells us we have 3 complete cycles in 360 degrees. And just like we do in class, we take 360, divide it by 3, and that gives me 120. That tells me that one complete cycle is 120 degrees. Common mistake people will make is they'll come down here and they'll write a 120 right there. That is incorrect. Had we started at 0 and gone forward 120, that would be correct. We did not start at 0. We started at 45. If we had started at 1 and gone forward 120, this would be 121. If we had started at 10 and gone forward 120, this would be 130. But we have started at 45 and we are going forward a distance of 120. 45 plus 120, we're at 165. And there you have your first one completely done. I should have left a little more gap here. So sorry, those two equations are running together. You do not have to have this 120 written here. I just always do that to show you how to get it. I am the teacher, right? But that is not necessary. Okay, the second one here, slightly more complicated because we're dealing in radians, 2 pi over 3. We'll deal with that two ways. Okay, but again, I'm going to draw just this long line, excuse me. And from this, I'm going to go ahead and draw up the figure. It says, well, actually, no, I won't. I'm going to change things up a little bit. Let's deal with this. The center line is -2. That goes right here, -2. And it says I'm going up 4. -2 plus 4, I'm going to go all the way up here to +2. -2, go down 4. I'm going to be down here at -6. This right here says I have a positive cosine wave. From your cheat sheet, you know what that looks like. This looked like this F, the sine wave looks like an S, and the positive cosine wave looks like a horseshoe. Kind of. Goofy horse, I guess. There's your positive cosine wave. Had it been had this been a minus, we would just flip it, draw a negative cosine wave. But right here is where we start. Right there. Again, I do not have it way over here against this y-axis, for lack of a better term there. Okay? And again, I'm going to leave this 2, the frequency, until the last step. Now, we're going to go ahead and do this in radians to begin with, and then I'll change it to degrees, which I know many people prefer just because they're more familiar with that. So, let's look at this. It says -2 pi over 3. So that means right here, instead of -2 pi over 3, I'm going to be at +2 pi over 3. This 2 tells me I get 2 complete cosine waves, 2 complete cycles in 360 degrees, or from your back of your cheat sheet, you know that 360 degrees is the same as 2 pi radians. So, earlier when I was using degrees, I did 360 divided by 3. Well, this is going to be 360 divided by 2, or 2 pi radians divided by 2. If we're in degrees, which we will do in a minute, we'll go 180. Since we're in radians, we're just going to go a distance of pi. I'm here at 2 pi over 3, and I'm going a distance of pi all the way to there. Well, what's 2 pi over 3 plus pi? Well, 2 pi over 3 plus pi, well, that's fractions. You've got to have a common denominator. That's 2 pi over 3 plus 3 pi over 3. 2 pi's plus 3 pi's, 5 pi's, 5 pi over 3. This point right here, chalk rope, is simply 5 pi over 3. You could have thought of this as going forward 3 pi over 3, same as pi. Okay? Now, I know you guys don't like that particularly. So, let's change it to degrees. You know how to change pi radians into degrees. For anytime you see pi, you just change it to the number 180. Okay? 2 times 180 is 360 divided by 3. This could have been x minus 120. Let me just do the math here. Make sure I don't embarrass myself. 180 divided by 3 is 62. Yeah, we're good. Okay? I could have called this 120 degrees instead of 2 pi over 3 radians. 120 degrees. I went forward pi radians, or I went forward 180 degrees. What is 120 plus 180? That is 300 degrees. There is your sinusoid drawn out. And again, I'm going to erase this 180 and this right here. If you have it in degrees, still, well, back up a second. Your center line still is -2. Going up 2, down to -6. Starting at 120 degrees, going forward to 300. Starting at 2 pi over 3, going forward pi radians to 5 pi over 3. A little more complicated because we're dealing with pi and we have to get common denominators and stuff like that. Well, I hope that was clear. Certainly when we get back together, we'll spend a lot more time on this. And just the biggest thing, again, third time I'm saying this, when you draw your sinusoid, do not start it way over here on the left-hand side. Come out a distance and draw the one sine wave, one cosine wave, or if they're negative, flip it over. Hope to see you guys real soon. We'll get fun math in here together. God bless you all. See you later.